Recording. Okay, go ahead and get ready to start.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is the second meeting this month for the DBA Fundamentals virtual chapter. Today's presentation is entitled Dr. DMVs Troubleshooting Toolkit by Glenn Berry. He's going to go through the entire thing. I'll be turning things over to Glenn in a few minutes, but I want to go over a few things, other things quickly. First of all, my name is Steve Cantrell. I'm Chapter Vice President of the DBA Fundamentals virtual chapter. This session will be recorded, and you can get to it via our website at DBA Fundamentals and look up at our archive section, or you can go to our DBA Fundamentals channel on YouTube. And as far as scripts, if there's any scripts, go and get those to us, and we'll post those on our website. This year, PASS is having a business analytics conference in California, Santa Clara, California, April the 21st and 22nd. And we have got a code that you can use that will give you $150 off. It's B as in Baker, A as in Apple, B as in Victor, C as in cat, D as in dog, and F as in fish. You can go to the TASBA conference website and check out a lot of pre-recorded sessions that they have already that you can look at over the weekend before you get there, or before you sign up. Next month, we have Dina Cherry on March the 3rd with I've Got a SQL Database, Now What? And on March the 17th, we have Paul Randall, the old right backup strategy. I think everybody's going to enjoy both of those, so go and sign up for those. It's all the housekeeping I can think of. You want to listen to Glenn, you don't want to listen to me, so I'm turning it over to Glenn right now.
Okay, thanks a lot, Steve. I'm going to go ahead and get started here. This is going to be Dr. DMV's Troubleshooting Toolkit, and there's my email address down there on the bottom of the slide. If you have any questions after this that we don't cover during the session, go ahead and email me. And I'll ask you to go ahead and hold your questions to the end, because I'm going to whip through the PowerPoint pretty quickly, and then I'm going to go into the demos, and that's going to take some time. And so if you have questions, please wait till the end if you can. So this is a little bit about me. This is the marketing slide. Basically, I've been around the SQL Server community for a number of years now, and I've written several books, and I am very active on Twitter, and I also develop a lot of content for Pluralsight, which I'll talk a little bit more about later. So what we're going to talk about today, and I'm going to whip through this PowerPoint pretty quickly because I don't want to punish you with PowerPoint, but basically any DBA quickly finds out that anytime there's any kind of a problem with the website or anything that an application is running, usually people tend to notice and they tend to blame the database right off the bat. And many times multiple applications are depending on a database server, and you can't just go in and reboot the server and hope that that fixes the problem. Usually it doesn't, and if you do, you can be down for a while anyway, so you can't do that like you can with a web server, for example. And if you don't already know this, DBA actually stands for Default Blame Acceptor. I can't tell you how many times I used to hear, what's wrong with the database? What's wrong with the database server? And I got really tired of hearing that as a production DBA because people always assume it's a database problem. And sometimes it is, and sometimes it isn't. And rather than just guessing what the problem might be, I started putting together these scripts to help figure out what the problem actually is. But the database is always guilty until proven innocent. So you need some tools and something you can do to quickly find out what the problem really is, because a lot of times it's not a database problem. So this is your nightmare on 32 cores. This is a pretty beefy machine from about, I don't know, a year and a half ago that was just brought to its knees by one bad query. And this is something you don't want to see as a DBA because it can be hard to fix this problem. And this is your nightmare on 120 cores. This is an even beefier machine that I brought to its knees running a benchmark program, but I've seen production database servers this same way. And of course, with Windows Server 2012 and newer, you've got a lot more information in Task Manager with a heat map for your CPU utilization. So I think DMV queries are a really good tool that are easy to use to figure out how your server is configured and how it's performing and what's going on with your individual databases. And this was added to the product way back in SQL Server 2005, so they've been around a long time now. And each new version of SQL Server has a few new improvements, a few new DMVs, and sometimes they add additional columns to existing DMVs. And they give you a lot of really good, useful information about your hardware, how your instance is configured, how your databases are configured, things like missing indexes, what your top weight types are, what your most expensive queries are. So a lot of really good stuff here that's very easy to get at if you just have a good collection of queries to run. And most of these queries are very, very lightweight. They don't put a big stress on your server, and they're easy to use. You just run them. The only thing you will need is view server state for most of them. Excuse me. And one other thing to keep in mind is that the information that's collected by these DMVs is not persisted between restarts of the SQL Server service or of the entire box. So if you need to keep these for trending or historical purposes, you might want to write them out to a user database. And I wrote a blog post, I don't know, about a year and a half ago, where I introduced this thing called the Server Monitor database that creates a little database, and then it creates an agent job that collects a few of these every minute by default. And you're welcome to download that and play around with it and extend it if you want to. It's completely free. So I started working on these way back in 2007, 2008, and then I started making them available publicly in April 2009. And there's separate versions for each major SQL Server version out there. And so each new version of SQL Server, the newer versions have more queries that I have in these sets. So it's important that you download the right version of the queries for your version of SQL Server, because if you run the wrong version, some of the queries just aren't going to work. And I usually update these every month and put them up on my blog so you can download them for free, and the URLs for that is right here. You can also just Google Glenn Berry DMV and you'll find them very quickly. So, just to summarize this is going to help you. You'll see as I go through the demo, you'll be able to detect many configuration performance issues and help figure out whether it's really a database problem or not. And they're very easy to use compared to a lot of other diagnostic methods. They're a lot easier, for example, than extended events are, even though extended events is much more modern. And just keep in mind that this information that they collect is not persisted between restarts unless you capture it to your own user database someplace. So I've got some references here, and then I just have a link here to my Pluralsight courses that are related to these queries. I have 3 separate courses that walk you through all of these queries and explain the reasoning behind them and how to interpret them in more detail than I can do in this presentation today. So that's it for the PowerPoint punishment. So now we get to the fun part. This is actually the latest and greatest version of the queries for SQL Server 2014. So that's when I'm running on my machine, and we're going to go ahead and run through all these, and I'll try to explain how you use them and how you interpret them as you go through here. So the first thing you want to do when you run this, just double check and make sure that you have the right version of the script for your version of SQL Server. And I do in fact have the right version, which is hopefully the case since I wrote them. But if you don't see this message, then maybe you downloaded the wrong version and you're going to have some problems later on. So the first actual query that I run here is figuring out the exact edition and version and edition and build of SQL Server. So I want to know, I've got SQL Server 2014 build 2480, and it's 64-bit version, and I'm running Enterprise Edition, and it's also running on Windows NT 6.1, which I happen to know is Windows 7 on my machine. And I've got a little build chart underneath all of these that shows you what these builds actually mean. So this is CU6 for the RTM version of SQL Server 2014 that just came out yesterday. And then I have a link here that takes you to the Microsoft Knowledge Base article that gives you all the CU builds, so you can go and download the latest one. Because what I find is a lot of customers that I run this on, they're running a really old version of SQL Server, and sometimes it's so old that it's out of support. And I'm a pretty big believer in trying to stay relatively current, especially on SQL Server 2012 and 2014, because every CU that comes out typically has anywhere from 30 to 60 hotfixes, and some of them are very significant. And I know there's a lot of people out there who don't believe in cumulative updates and they wait for a service pack, but for those people, Microsoft's probably going to ruin your party pretty soon because it looks like they're not going to do service packs in the future. They're moving to a new model. They haven't officially announced it, but they've dropped plenty of hints about this. So there may not be any more service packs in the future. So you're going to have to change your thinking to embrace cumulative updates. So anyways, one thing I want to point out is this is another knowledge base article that came out late last year where Microsoft basically recommends staying current on CUs, and they also point out a lot of trace flags and other configuration options that you want to think about turning on your machine to get better performance on SQL Server 2012 and 2014. So it's a really handy article. So going on, the next query I want to run is I want to find out when SQL Server was actually installed on this instance. And in my case, it was installed last April. But I want to know that because I want to have an idea, number one, how old is the hardware and how long has this instance been running. If it's been running for 5 or 6 years, that's different than just 5 or 6 months. There's more likely to be problems if it's been running a long time, for example. The next query is going to call server property multiple times and pull back some useful information about the hardware and the instance and the server itself. So this is going to show me the name of my machine, the name of the server, the fact that it's not a named instance, I'm not clustered. It's going to show me again the edition, which is Enterprise Edition. It's RTM, I don't have a service pack yet. The build, there's the process ID for the SQL Server service, my collation, and a few other things about whether or not full text search is installed and what's going on with security, and a few other things that were added for 2012 and 2014 as far as hackathon and always on availability groups. So you get all that information from that. And again, the scenario here is think about you're a brand new DBA or you just got a job in a new company and they've got all these SQL servers that you didn't set up and you don't know that much about them. And so you're going to run this set of queries to figure out what's going on with them. So that's what we're doing here. And we start off running instance level queries and then we're going to go into database level queries later on. So query number 4, I want to find out what SQL Server agent jobs I have on this instance and find out a little bit more about them. So this shows me I've got the Ola Hallengren maintenance solution installed, which I highly recommend, by the way. Excuse me, and it shows me that SA is a job owner for all these, which is good. That's what you want instead of an individual login. And it shows when the job was created and the fact that it's enabled. And then I don't have notify email operator set up, which is bad. And if it was a production server, I wouldn't want this. And then it also shows me the category for each one of the jobs. So going on, the next one is I want to find out if I have any SQL Server agent alerts on this server. And agent alerts are different from agent jobs. These are things that you can set up to react when certain errors occur. And then rather than just having to find them in the SQL Server error log, you can have it so it notifies somebody by email or to a pager or a smartphone when a certain error occurs. And it's better that you find out now rather than when the users start complaining tomorrow morning. So I've got a script that I wrote, and it's on my blog, that will create all of these alerts automatically on your machine. All you have to do is make sure you have a SQL operator defined. And then it will create all these alerts using the name of your machine as part of the alert name. And that gives you pretty good protection against a lot of different issues that you might run into with your hardware and with your SQL Server databases become corrupted, for example. So the next query, query number 6, is DBCC trace status -1, and that's going to show all the global trace flags that are enabled on my instance. And we always recommend to people that they turn on trace flag 1118. What that does is it changes how extents are allocated in TempDB so you get more even allocation. There's really no downside to turning this on, so we recommend that everybody always turns this on. Another one that we recommend that everybody turns on is 3226. And what that does is normally whenever you run any kind of a database backup, whether it's a full or differential or log backup, you get a message in the SQL Server error log that says that the backup completed successfully. Well, that's not really very interesting to see that. What you want to see is the message that it failed. So if you turn this trace flag on, it'll suppress writing the successful log backup messages to your error log. You'll still get the ones if it ever fails. So that way you have less meaningless information in your error log, and it's easier to find interesting stuff. So going on, the next query, I want to find out some more information about Windows, that I'm running on for this server. And this tells me that I've got Windows 6.1 and Service Pack 1, and then it tells me the SKU and the language. And I've got a little chart down here that translates this. So unfortunately, we can't tell the difference between Windows 7 and Windows Server 2008 R2. We just get a 6.1 back. So we know it's one of those two. And then we can tell the Service Pack. And then the SKU tells us whether it's Enterprise Edition or Standard Edition or Data Center Edition. And then the language 1033 is US English. So we find all that out about our server. Next, I want to find out about the SQL Server services for the database engine here. So this shows me that I've got the SQL Server database engine and then the agent, and it shows their process IDs, and they're both set up to start up automatically, and they're both running. And then it shows me the last time the SQL Server service started, which is really important to know because whenever you restart the service, that clears out all your DMV stats. And I want to know, did it start, a few hours ago or a day ago, or is it 6 weeks ago or 6 months ago? That's just important to know. And then it shows me what account I'm using for these services. I've got a local account on my workstation that I'm using. And then it shows me that I'm not clustered. And then since I'm not clustered, my node names are null there. All right, moving on, it's going to tell me, the next query is going to tell me about my NUMA nodes. And NUMA stands for Non-Uniform Memory Access. And all modern Intel and all AMD servers have NUMA support rather than SMP like older processors did. And since I just have a workstation here with one processor, I have one NUMA node. But if I had a 4-socket server, for example, that normally would be set up with 4 NUMA nodes unless somebody turned off NUMA in the BIOS. So anyways, by running this query, I'll find out what's going on. And if some knucklehead turned off NUMA, then I'll know. And I run into that a lot in my consulting business, problems that I see when I run these queries. So moving on, this is one of my favorite queries. This one is going to give me some hardware information about my server. And a lot of organizations don't let the DBA RDP directly into the database server. All they can do is connect with Management Studio. So if you're in that situation, you may not know some of these gory details about your hardware. So this query tells me that I've got 1 physical CPU, and my hyperthread ratio is 8, and then my logical CPU count is 8. And unfortunately, this query can't tell the difference between physical and logical CPUs. It just knows that I have 8 logical CPUs. And it turns out that I've got a quad-core processor with hyperthreading enabled, so I have 8 logical CPUs. And then I've got 32 gigs of RAM on this workstation. And then it tells me a few other things. And again, it tells me when SQL Server started here. And then one last thing I want to point out about this query is where it says virtual machine type. If this comes back and says hypervisor, that doesn't mean that you're running inside of a VM necessarily. What it means is that there's a hypervisor running on your machine. So you could be running outside of the hypervisor or you could be inside of the hypervisor, but you can't tell from this query. And a lot of people get confused about that. All right, the next one is going to tell me who made my server. And it turns out that I made it out of parts. But if this was a Dell or an HP or whatever, it would say, Dell PowerEdge R720. It would give you the model and manufacturer, which is very useful to know when you're trying to figure out the capacity of the server and how old it is, for example. Now the next one, which only works in SQL Server 2012 and newer, is going to tell me what's going on with the licensing on this server. So this is saying, okay, you've got 1 socket with 4 cores and then 8 logical processors, and then it's using 8 logical processors for licensing. And see, where you'll run into problems here is, for example, with SQL Server Standard Edition. SQL Server Standard Edition can only use 16 physical cores or 32 logical cores. So if you go out and buy a brand new 4-socket or even a high-capacity 2-socket server, you might have more cores in the machine than SQL Server Standard Edition lets you use. And you might not even realize that SQL Server is not using your entire box until you run this query, and then it comes back and tells you, well, you've got 48 cores, but SQL Server is only using 32 of them. And I just ran into that with a customer last week. So this is a fairly common problem. All right, the next thing, this query number 13 is going to tell me what kind of processor I have. And I really want to know that because it's important for licensing purposes, it's important for performance and scalability purposes. And I'm a hardware guy, so I'm always interested in this. So I've got a Core i7 3770K processor. And this 3.5 gigahertz is the rated base clock speed of that processor. It's not necessarily the speed that it's running at right now. And that can be affected by your Windows power plan or hardware power management at the BIOS level or at the hypervisor level. So this just tells me what it should be running at for a base clock speed. All right, the next one is if I had a failover cluster, which I don't, this would tell me some information about the failover cluster and how it was configured. In the same way for this next one, it would tell me some information about the failover cluster, which I don't have here, so I'm just going to kind of skip that. And then this one also is about failover clusters. It would tell me about all the nodes and which node was the current owner of the SQL instance that I was connected to. And then the next one is for always-on availability groups. If they're using failover clustering also, they would give me some information about the cluster name and what kind of quorum and the state of the quorum we had. All right, getting on to the more interesting ones for standalone servers, this one is going to give me all the instance level configuration values for the server. And there's 70 different configuration values here on SQL Server 2014. And there's certain ones that I always focus on. So for example, I think backup compression default should be turned on in most cases. It's usually a big net win to use backup compression. I want to know is the CLR enabled or not. I also want to know what the cost threshold for parallelism setting is. That controls how expensive a query has to be before it gets parallelized, and the default is 5, and most people for most workloads end up raising that to a higher value, but that's just something you need to think about based on your workload. Next one I like to look at pretty closely is max degree of parallelism, and the default is 0, which means it's going to use as many processor cores as it wants to. There's certain situations where you might want to change that. What we typically recommend to people is that they set it to the number of physical cores in a NUMA node. So if you've got an 8-core processor, for example, you might set it to 8. And certain products like SharePoint recommend that you change it to 1. But outside of that, usually it's a bad idea to change it to 1, which a lot of people do anyways. And then I want to know max server memory. I've got it set to an artificially low value of 8,000 megabytes right now. But I just want to know that. It should be set to an appropriate value based on how much memory you have on the box and what SQL Server components you have running, and also if anything else is running on the box. You need to take all that into account when you decide what to set this to. And then finally, this one right here, optimized for ad hoc workloads. That was added in SQL Server 2008, and what it does is it lets SQL Server just store a stub of the query plan instead of the entire query plan for an ad hoc or prepared query the very first time that it's executed. So it takes up less space in the plan cache. And that sounds like a good idea, and it is, but unfortunately what ends up happening a lot of times is even when you turn this on, you still have problems with plan cache bloating because lots of stubs get in there instead of full plans. So it helps with the problem, but there's something else I'll explain later that helps as a band-aid to help control that plan cache bloating issue. All right, moving on, the next one I want to talk about is buffer pool extensions. And that's a new feature in SQL Server 2014 that's also in Standard Edition. It's not just an Enterprise Edition, but what it lets you do is that you can create a cache file, and it should be on flash storage, but Microsoft doesn't enforce that. They'll let you put it on a thumb drive if you're going to be dumb. But what it's supposed to do is the idea is that flash storage has better random I/O performance than typical magnetic storage or SAN. So the thinking is that you can set aside some space on your flash storage, and then SQL Server will cache clean buffer pool pages in this cache file. And you can get better performance in some scenarios by using this. So the idea is that maybe you've got a relatively low performance SAN that you're stuck using, and you can go out and buy a relatively inexpensive SSD and throw it in your SQL Server machine and then set aside some space on that and get better I/O performance. It doesn't always work as well as you might hope in real life, but it's an interesting feature to experiment with. And so this shows me that I have it turned on and how big it is. And then the next query is going to show me whether or not I'm actually using that file. So when I run this query, it'll show me, and it takes a few seconds to run, that sure enough, based on some of the stuff I was doing before this meeting started, I've got some usage of that file. I've got a database called no compression test that's using about 17 gigs in that file. And then this other database is using 230 megabytes. So I am actually getting some use out of that. All right, going on, the next query, it helps you do some network troubleshooting. So this is going to show you the TCP listener and what port it's using and what IP address. And so everything's local on this machine right now, but that's what's going on with my TCP ports. The next one is it'll show you if you have any memory dumps that SQL Server has generated. You don't want to see any results here. Basically, SQL Server, short of crashing, can have a problem from time to time where it decides to do a memory dump. And if that's happened, then you'll see a record of where it happened and what time it happened and how large that memory dump is. And if you really know what you're doing, you can crack open that memory dump file and see what's going on. But what most people end up doing is sending that to Microsoft to have them look at it to try to figure out why did you get a memory dump, because you don't want to see that. Now the next query is going to look at TempDB and all the other databases on this instance and tell me where they're located. So it's going to show me how they're spread across the file system. So it's going to show the data file and the log file, and so you can see I have a C drive and also I have an L drive, and I've got things spread across them a little bit. I've got TempDB on the L drive, and then I've got one log file here on the L drive, and everything else is on C. And it tells me some information about whether or not percent growth is on, which is a bad thing. You don't ever want to use percent growth for your data files or log files. Shows you how big the growth is set to and then how big the file currently is right now. All right, so then moving on, and again, you might notice that underneath all these queries, I've got a few notes on how to interpret. And if you want to get more information about how to interpret these, you should listen to my Pluralsight courses where I go into a lot more detail. So going on, the next one is going to give me some information about all the volumes on this server that have any SQL Server database files on them. So I've got a C drive and an L drive, and they're both using NTFS, and that's the logical volume name, and that's how big they are. They're both SSDs in my case. And then that's how much space I have free. So I'm getting a little bit low on disk space on both of these. So now I know that, which is nice to know because especially with magnetic storage, as it gets more and more close to being full, the performance goes downhill. And you even have a similar effect with solid-state storage. As it gets closer to being full, performance is affected when it tries to do things like trim operations and garbage collection. So the next one is going to tell me if I have any 15-second I/O warnings in the last 5 SQL Server error logs. So hopefully I don't have any with my solid-state storage, but a lot of production servers, especially when they have relatively poor performing I/O subsystems, you'll see 15-second I/O warnings, and that's basically SQL Server screaming that it took 15 seconds or longer to get an I/O request. And what's nice about this, if that's happening, is that it'll tell you what file and what drive were involved. And a lot of times when you look at this, you'll see a pattern. So maybe every night at 3 a.m. when you're doing something like rebuilding indexes or doing some other very intensive task, you'll see warnings happening over and over at the same time. You may not see a pattern. Maybe it's just happening all the time because your I/O subsystem is just really bad. And so this is some of the evidence you're going to collect when you go to talk to your SAN administrator about why your I/O performance is so bad. And of course, quite often the SAN administrator says, oh, there's no problem. The SAN looks fine to me. But when you start collecting evidence like this at SQL Server's level, that helps bolster your argument. So the next query is something I stole from Jimmy May and then cleaned it up a little bit. But what it does is it tells you your I/O latency at the drive level. And it helps if I show the results. So anyways, this shows me for the L drive and the C drive, and this is the read latency and the write latency in milliseconds at the drive level. And this is for all the SQL Server files since SQL Server has been running. And so you need to keep that in mind, because if you've done something like, this includes things like backups and index maintenance and your normal workload. So you want to see these numbers under about 25 milliseconds if possible. So if you run this and you see something like 500 milliseconds for writes, that's something you want to start thinking about and investigating. That's really pretty bad. So the next one takes that and drills in to the file level for all your database files. So this is going to show you, okay, here's my data file and here's my log file, and this happens to be the data file for this AdventureWorks database, and you can see the read latency is relatively high, excuse me, to all the rest of these. So it tells you the read and the write latency and then the average between the two, and then the size of the file and where it's located. And then it also gets into some information about the number of reads and the number of writes, and it also shows you whether Resource Governor has been involved here, because they enhanced Resource Governor for SQL Server 2014 to let you control I/O to a certain extent. So this helps you start to characterize and understand your I/O workload. So you could see that, oh, I'm getting lots of reads from this file, this no compression test data file, for example, and only no writes at all. So it helps you understand your workload. All right, moving on, the next query is going to show me some information about all my databases on the instance. So when I run this, it shows that, okay, I've got a fairly small number of databases, shows the recovery model, shows the log reuse weight description, which is really important in real life. You want this normally to be nothing or log backup if you're in full recovery model, but if it comes back with something different like replication or database mirroring, then that's something you want to look into, because this is what's preventing the log from being released and cleared so you can reuse those segments inside of the transaction log. And it tells you how big the log is and how much of it's been used and the percentage that it's been used. And see this one right here? Good old VentureWorks 2008 R2, he's used 94% of his log space, and he's waiting on a log backup. The last time that it checked, that was the log reuse weight description. So that means we've basically got what's called a runaway transaction log. Some bad DBA is not running log backups frequently enough, and so the log is filling up, and when it fills up, it's going to grow, and then it'll grow if it can, and it'll keep on doing that until it runs out of disk space, and that's one of the most common novice DBA mistakes, is to have a runaway transaction log. So here, sure enough, I've got that. And this also shows some other very useful information. It shows me the compatibility level. So these guys are all set to SQL 2014 except for this guy. It shows me the page verify option, which should always be checksum as opposed to torn page or none. It tells you some information about create stats and auto-update stats asynchronously, forced parameterization, snapshot isolation, read committed snapshot, auto-close, auto-shrink. Neither one of these should ever be on, in my opinion. The target recovery time in seconds, that's a new feature they added in 2012 that lets you vary that at a database level. Whether or not you've got change data capture enabled, whether or not you've got hackathon going on, and where you have delayed durability, which is a new feature in 2014 turned on, and then where you've got auto create stats incremental enabled. So again, you're finding all this information about your databases and looking for common problems. And I guarantee you, when I run this on people's production databases, I find lots and lots of things that are wrong that are quite often very easy to fix without any kind of an outage. So the next query is going to show me the missing indexes for all the databases on the instance ordered by this index advantage. An index advantage is just a calculated number that's based on how often it's wanted and how costly it is not to have the index, essentially. And so you want to look at this number, and then you want to know how long has your server been running, because if it's only been running for a few hours or a few days even, you're going to have smaller numbers. Whereas if it's been running for months, the numbers are going to tend to get larger for these missing indexes that SQL Server is asking for. The other thing I always want to look at right off the bat is when was the last user seek for this index that SQL Server thinks that it wants. Because if it was 2 months ago and it hasn't happened since then, that means it was probably some one-off ad hoc query or some very seldom run reporting query, and it's probably not as important to your overall workload. Whereas if it happened just a few minutes ago or a few seconds ago, and then you run the query again and it happened again, that means that it's part of your normal workload and it's probably more important. So I always look at these two right off the bat. And then it tells you which database we're talking about, and then the schema and the table. And then it gives you what columns that it thinks that it wants this index on. And so the equality columns, and then the inequality columns, and then the included columns. And then going over to the right, this average user impact number, that's the percentage of the cost reduction that you would see if it had this index for that particular query. So if it's 98%, it's claiming that the cost of this query would be reduced by 98% if you gave it this index. And the next column over is the average total user cost, and this is just a relative number that's supposedly, according to legend, based on some developer at Microsoft had a machine on his desk back in 1998 or something. And so all this really means is just higher numbers are more costly, more significant. So you can see that 18 is quite a bit higher than 0.03. And then the user seeks number, that's the number of times that SQL Server has wanted that index. So, I want to look at that, and is it tens of thousands or hundreds of thousands of times that it's wanted, or just once? That's going to help me decide whether I think I want to add this index. And then finally, what I'm going to think about when I'm looking here is quite often SQL Server will ask for lots of narrow indexes, and lots of indexes that are very similar except for one column in the included list, for example, is different. So what you want to think about is, can I take 2 or 3 or 4 or more of these suggested indexes and combine them into a wider composite index that covers more queries? Because every index you add is going to hurt your insert, update, delete performance. And you don't want to go crazy here. The worst thing you can possibly do is run this query and just create every single index that SQL Server is asking for. You're going to over-index your database very quickly if you start doing that. You want to use your judgment and look at your existing indexes and think about your workload and decide what to do here. So I've just had a lot of nightmares from people running this and losing their minds and creating 50 new indexes. That's usually not the right thing to do. So the next query I got from Michelle Uford, and what this does is it gives you your VLF counts for all of your databases. And what a VLF is, VLF stands for virtual log file. And whenever you grow the log file, whether it's an auto grow or you manually grow it, it adds additional VLFs inside of the log file. And the number of VLFs you get depends on the size of the growth. And the way that's done also recently changed in SQL Server 2014, and Paul Randall wrote a really good blog post that explains how that works. But what you need to keep in mind here is as the VLF count gets higher, that affects the recovery portion of a restore. And it also comes into play during crash recovery. And so things such as failing over a failover cluster from one node to another, you have to run crash recovery on all the databases as you start SQL Server. And that's going to make your failover time be much higher when your VLF counts get higher. It also can hurt the write performance of the transaction log file. So you want to keep these counts under control. And the way you keep them under control is that you make sure that your auto growth is set to a reasonable size, and then you manually grow the transaction log in reasonably sized chunks till it gets to the desired size. And if you didn't do this from the beginning when you created the database, the way you fix it is you run a transaction log backup if you're in full recovery model, then you shrink the log file, and you may have to repeat that 2 or 3 times, and then you'll get the VLF count down. And then, of course, your transaction log will be very, very tiny, so you want to immediately grow it in large chunks, such as 4,000 megabytes or 8,000 megabytes for larger databases until it gets to the size that you want it to be. And if you do that and set your auto growth properly, you won't have an issue with this. But I see lots of databases where the VLF counts are really high, and it's something that's easy to fix. All right, so going on to the next query, this is going to tell me the CPU utilization by database for all of my databases on this instance. I want to know which database is using the most CPU. And so since I was purposely slamming this database earlier, it's using 89% of the CPU since SQL Server has been running. So that's something I want to know because it may not be obvious when you've got lots of databases on an instance. Now the next query does the same thing except for I/O. Which database is sucking up most of the I/O on the instance? And it turns out a different database, this one here, uses 96%, almost 97% of the I/O since SQL Server's been running. And this includes everything that's been done to that database. So your normal workload, your maintenance, and your backups, all of that's included in this I/O statistic. And then the next one is going to show me the same thing except for buffer pool usage. Which database is using the most space in the buffer pool cache? So it's this guy. He's using a lot of space in the buffer pool cache. And that includes, in this case, the actual buffer pool cache plus that BPE file is together for this because SQL Server sees them as equivalent. All right. Moving on is the infamous Topweight Types query. And the reason why I say it's infamous is that people quite often lose their minds about this query. And what I mean by that is if your server's running well and nobody's complaining and you can have plenty of time to play solitaire at your desk, then you shouldn't lose sleep about whatever the top weight type is here. Where this is more useful is when people are complaining and the server's running poorly. Then you run this query and it'll tell you what SQL Server spent most time waiting for since the last time it was started or the last time you cleared the wait stats. And so this shows me in my case 30.11% on this particular wait type. And that's the other reason why I call this the infamous query, because there's a lot of bad information on the internet about what the wait types mean and what you should do, if anything, about them. And sometimes the wait type names are deceptive. So if you ran this and saw async network I/O, you might go screaming at your network admin, what's wrong with your network? Why is the network so slow? And usually for this wait type, the network is not the problem. It usually means that the client is taking too long to get the information back from the server. It's not really the network at all. But my point is that rather than just doing a knee-jerk reaction, as Paul Randall likes to say, you want to think about what you're seeing here, and this can help point you in one direction or another, but you just need to do some quality research and think about what you're reading, and don't just find one blog post or forum post that says, oh yeah, if CX packet weights are high, you should change max stop to 1, and that'll fix the problem. That's bad information. You don't want to do that. And so anyways, with all those caveats, if you use these properly, they can help point you in the right direction. So maybe it's an I/O problem, or maybe it's a CPU problem, or maybe it's a memory problem. So that's what this is really good for. And what I like to tell people to do is, if your server's been running for quite a while, and then you make a change, like you change your max stop setting, or you add an index, or something like that, you might want to clear your wait stats with this command right here that I have commented out. If you run this command, it'll clear the wait stats, and then you wait a little while after that and then run this again and see what your top weight is now, because maybe that setting that you changed or that index that you added changed the whole equation for SQL Server, so it's waiting on something else instead of what it used to be waiting on. All right, and then I've got quite a few links here that explain all of this in some more detail. All right. Now the next query is going to tell me the signal weights for the index, for the instance. And what signal weights are is basically waiting on CPU. And so it's going to show you the percentage of signal weights, and this is quite high. And that's on purpose, since I was running something earlier to really slam the CPUs on this. If I saw this on a production server, that would be a pretty good indication that the server was under CPU pressure. Resource weights are anything besides CPU-related weights. All right, the next one is what logins are connected and how many connections do they have? And since I've got, SA being used by my little benchmark program, that's where this is so high. But this would tell you, and this is good for troubleshooting, because I can't tell you how many times people have come to me and said, well, I can't connect to your database server from this web server. And usually it's some problem with a firewall or the connection string is wrong. But when you run this, you can see who's connected and how many logins they have open. And this is another way of looking at it. You can get the SQL connections by IP address. So on a real production server, it would show you all the different application and web servers that were connected to your server. So if they were complaining that this particular web server couldn't connect to your server, you could see, well, it's got 20 connections open right here. I don't know what your problem is. So anyway, what's going on? Now I'm going to get the average task counts. And this is something you want to run multiple times. And what I mean here is that this is going to change from second to second. And it's very useful for some just high-level troubleshooting, because when average task counts go above 10 roughly and stay there, that's usually a pretty good indication that you're seeing lots of blocking and maybe deadlock type issues, or it could just mean that your server's really, really busy. If average runnable task count goes above 0 and stays, that's a very good indication of CPU pressure. And then if average pending disk I/O count goes above 0 and stays there, then that's another good indication of disk pressure of some sort. So this is a nice thing to run, but you can't just run it once and say, oh yeah, everything looks good now, because it's going to change from second to second. All right, the next one, SQL Server keeps track of its CPU utilization every minute automatically in the ring buffers DMV. And so you can go back in time about 4 hours and see what's been going on. So if you go back a little ways, you can see when I was slamming my server, 81 minutes ago and 83 minutes ago. You can see the time here. And this first column is how much SQL Server was using. And then this column on the right here is what other things on the box were using. So it turns out when I was doing this, SQL Server was using 33%, and then SSMS, Management Studio, was using 11%, for example. And then this is how much was left for, idle. So this is it's nice because if people are complaining that the server's slow, you could run this query and you can say, oh yeah, the processor's been pegged for the last 90 minutes. Or you can say, well, it's only been going on for the last 5 minutes, so you get a little bit of look back into time by running this query is what it's useful for. All right, this next query is going to give me my top worker time queries for the entire instance. And so if I've got multiple different databases, this shows you which query or stored procedure, and so here's the name of the stored procedure, for example, is using the most worker time. And worker time equates to CPU effort. So if you're under CPU pressure, you want to look for the highest worker time queries. And so here, now I know these 3 from this database and this one from that database were causing the most CPU pain. And I can even get the query plan here. So if I wanted to, I could click on this and see the query plan for that and see perhaps why it's so expensive for the CPU. All right, almost done with the instance level queries. So the next thing I want to find out is what's going on with the memory at the operating system level, and that's what query 41 tells us. And this tells me that I've got 32 gigs of memory in the box, and I've got about 20 gigs available because I've got max server memory set artificially low at 8,000 megabytes. And then it tells me how big the page file is and how much of it's available. And then this is a flag over here, the system memory state, and it can say available physical memory is high, or available physical memory is steady, or available physical memory is low. And you want it to say high. If it's one of those other ones, that means that the operating system is complaining that it's under memory pressure, and it's going to be signaling to all the applications such as SQL Server that they should release some memory, and you don't want to see that. So normally, unless you've done something wrong, you're going to see available physical memory is high when you run this query. Now the next query drills into the SQL Server process to find out what it thinks about memory usage. So this tells me, okay, SQL Server is using this much memory, about 8,094, and it also tells me that large page allocations are not enabled and locked pages are not enabled, which normally on a real server I would want locked pages enabled. And it also tells me these are flags for the process, and you want these both to be 0. If these are 1, that's saying that the process is under memory pressure, and you don't want to see that. Okay, the next one is page life expectancy for each NUMA node. And this is going to tell me the page life expectancy for each NUMA node in my machine. I only have one NUMA node. And on an idle server, if you wait a few seconds, it's going to constantly be going up. As you can see here, if I wait a second or two, it's going up. And you know, there's some old bad information on the internet that 300 is your threshold. If it's below 300, everything's bad. And if it's above 300, everything is good. And that's not valid information. It depends on how much memory you have in your server. And higher values are always better. But what you want to do is watch the trend over time and be aware of, okay, well, every morning when people come in and log into the system, my PLE goes down a little bit. But then as they take their coffee breaks and stop working as much later in the morning, it starts to rise, and here's my range. You want to look at it that way instead of saying, well, if it's above 300, everything is good. That's not the way to think about that. All right, this next one is memory grants pending. And you need to run this multiple times, and you want that to be 0. If you run it and it comes back above 0, that's basically SQL Server screaming that it's waiting on a memory grant, and you don't ever want to see that. And usually if you do see that, you're going to see that your PLE is really low, and you might see that your process is complaining about being under memory pressure. There'll be other signs, but this is the final confirming red flag that you're under memory pressure if you see memory grants pending above 0. All right, so if you're starting to see symptoms of memory pressure, then looking at the memory clerk usage for the instance can help you figure out what's using all that memory. So when you run this, what you want to see is this first one, memory clerk SQL buffer pool. That's a new memory clerk type they added in SQL Server 2012, and you want that to be using most of your memory. That's your SQL Server buffer pool. But what you're probably going to see on a lot of people's systems, unfortunately, is you're going to, and I don't see it on mine because I don't have that kind of a workload, you're going to see cache store SQL CP as one of your top memory usage types. And what that means is ad hoc and prepared query plans in the plan cache, that's how much memory they're using. And even with ad hoc, optimized for ad hoc workloads enabled, quite often you'll see this memory clerk right here using 4, 6, 8 or more gigabytes of memory. So there's something you can do to help fix that. It's sort of a band-aid, which I'll talk about in just a little bit here. So if you did see that, then what I'd want to do is run this next query. And this is going to tell me, okay, which one of those queries, or which queries of that sort that are ad hoc or prepared are using the most memory in the plan cache. And also, it's going to look for ones that have a use count of 1, which means they've only been used one time, yet they're taking up lots of space in the plan cache. And since I only restarted my server earlier today, I don't have too much interesting in here, but on a production server you'll see lots and lots of entries in this typically. And so you can copy the query text out of here and paste it into a query window and hopefully get an idea of what that query is doing and maybe who wrote it and who you need to go talk to about why are you doing this, why do you have a query that's using so much memory. And this is the little band-aid that I described earlier. If you run this command right here, dbcc free system cache SQL plans, and you can have an agent job that runs that periodically, once a day, once every 8 hours, whatever, it depends on your situation. That'll help control how much memory is being wasted on these ad hoc plans that are very unlikely to be reused and they're just wasting memory. All right, so that's all the instance level queries. So what you want to make sure you do now when you're doing this is that you switch to your database. That's why I say use your database name. And lots of people have complained, well, I don't have a database called your database name. But anyways, hopefully you switch to the database that you're most interested in, which I've done up here, and then run the rest of these database level queries. Otherwise, you're going to get all this information about the master database. So when I run this query, excuse me, this tells me information about this particular database as far as the data files and the log files and the file groups that they're in. It tells me how big they are and how much space they have available. So, you know, you can see I'm running low on space on my log, and my log is bigger than my data file. So I've been a bad DBA. I've let this log fill up and grow multiple times. The next I want to find out is some I/O statistics for this database. So this is going to break down this one database and tell me again where it's located and how big the file is and the number of reads and number of writes. So you can see lots of writes to the log file and very few reads, and then not too many reads or writes to the data file. And then it tells you I/O stall reads and writes and the percentage of reads and writes. So again, what this is helping you do is figure out, is it an OLTP kind of a workload with lots of writes to the log file and a decent amount of writes to the data files, or is it more of a reporting workload with lots of reads from the data file, for example? This will help you figure that out rather than just guessing. All right, now this next one is going to tell me my top cached queries by execution count for this database. And this shows you the execution counts, and then it tells you information about how many rows have been returned total, and then the last time it was executed, and the minimum rows and the maximum rows. And then these times are in microseconds when you see elapsed times here. And then here's the actual query text. So this helps me figure out, which queries are being executed the most often. Now the next one is do the same thing for stored procedures. So when I run this, it tells me which stored procedures in this database are being called the most often. Again, this is coming from the plan cache, so it's only going to pick up stored procedures that are in the plan cache. But now I've got a list. So hopefully on your most important databases, you're going to be familiar with the top offenders here. This guy gets called a lot. And I should know that he's normally called 1,500 times a minute. So if my company runs a Super Bowl ad and that goes to 15,000 times a minute, I would realize something changed. So this is one reason this is useful. Another thing this is useful for is that maybe one of these stored procedures is something that could be cached in the middle tier. Maybe it's getting the list of all 50 states in the United States and it's being called 5,000 times a minute. And that information is not likely to change anytime soon, so it's a very good candidate for caching. So you should be looking for caching opportunities when you run this. All right, the next one is going to give me the top cache store procedures by average elapsed time. And again, these times are in microseconds, not milliseconds, so it takes a million microseconds to be 1 second. So this is where you can look like a superstar. If you run this on a particular database and you find a store procedure that takes 30, 40 seconds, and you go in and do your store procedure query tuning and index tuning magic, and you make that store procedure come back in 1 second or less than a second, people are going to think you're a genius. And you need to make, if you do that, you need to make sure you take before and after metrics and let your boss know that, hey, I made the store procedure go from 40 seconds to half a second, because aren't I smart, is the implied message there. But it's a good thing to do, and you can find low-hanging fruit, easy query tuning opportunities by running this query. This next one is a similar one that is going to show you the highest execution time ones and show you the variability in the times. So it gives you the minimum time, the average time, and then the maximum time, and then the last elapsed time. So if you're seeing wide variations here, you might have a parameter sniffing problem, for example, or a plan stability problem. There's different things that could be going on where sometimes when you call this store procedure, it's really fast, and sometimes it's really slow. And this helps you find the ones that are doing that. You can look at them more closely. All right, going on, and this little set of queries that we're doing right now, this next 4 or 5, what I used to call the bad man list when I worked at NewsGator. And what I mean by that is every week or so I would run these on our most important database and then save the results in a spreadsheet and then send it out to all the developers. And the developers knew which store procedures they wrote and which ones they last touched. And if they were at the top of the bad man list for these different queries, that was sort of embarrassing, and they didn't want to be at the top of the bad man list. And it was a good way to help everybody work together as a team to work on the most expensive queries and just make the server run faster. And because the developers, they wanted to do the right thing, but they didn't know until I started doing this which queries were the most expensive. So anyways, this next one It does the same thing for total worker time. And if you were under CPU pressure and you figured out, okay, it's this database is causing most of the CPU pressure, now you run this query and it tells you, okay, this store procedure or this top 3 store procedures are causing the most CPU pain for this database. So here's one right here called get event log by feed ID, and you can see the total worker time is quite high compared to, the numbers drop off pretty quickly. These top 2 are quite a bit higher than this one, and then it goes down pretty significantly. So I'd be looking at these 3 right off the bat to try to figure out why they were so expensive. You can do the same thing for logical reads, and logical reads means that you're finding the data in your buffer pool. And so this helps you figure out what's causing the most memory pressure and indirectly read I/O pressure. So again, this is showing that these top 2 are quite a bit higher than all the rest of them. So I'd be looking at these 2 to decide what's going on here. Do I need to tune this query a little bit? Do I need to add an index perhaps to help reduce this? Moving on, we can do the same thing for total physical reads. So physical reads means that you're not finding it in the buffer pool and you're having to go out to the I/O subsystem, which is a lot more expensive even with flash storage. And so these 2 guys have quite a few physical reads, so I'd want to look at them. The next one does it for logical writes. So I would run this, and this would tell me which store procedures were causing the most writes, and you can kind of tell by the names, update, 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 that they're doing writes. And so maybe we can look at how often those guys are called, and maybe they're updating more columns than they need to. There's things you might be able to do to reduce this. Then the next one is going to focus on I/O. It's going to give me the statements within the store procedures that are generating the most I/O. And so here's the store procedure and the average I/O for this statement. And this particular statement in that store procedure is causing the most I/O pain. All right, these next 2 I like to call the Goldilocks queries, because this one is going to tell me indexes that have more writes than they do reads. And what that means is that you're paying the cost to maintain that index and you're not getting as much benefit. And in this case, I have lots of writes and 0 reads. But that doesn't mean I just want to go and drop this index right off the bat, because I need to understand how long has my server been running. If it's only been running for a day or 2, then it's probably way premature to be thinking about dropping the indexes, because maybe there's a bunch of queries that only get run once a week when reports are run. And if you go and drop that index for that, then the report goes from a few minutes to a few hours, and you're in big trouble. So what you want to do is understand how long your server's been running and understand whether or not you've seen your complete business cycle, and then do a little bit of research, maybe do some searching in the source code for your application, and try to figure out, do I really need this index or not, and then start dropping indexes one at a time. Don't just go crazy and drop 20 indexes because this thing says you should do it. Now moving on, the reason I call it the Goldilocks query is the next one is the missing indexes query that I showed you before, but this is filtered for this database only, and it also over here at the right gives you the table name again and then the number of rows in the table. And I always want to know that when I'm thinking about creating an index, especially if I'm on Standard Edition, because Standard Edition doesn't have online index operations like Enterprise Edition does. So if I see a table with 500 million rows in it, depending on how fast my I/O subsystem is, I'm probably not going to want to do that with Standard Edition in the middle of the day, because it's going to lock the table and cause problems that people will notice. And what I always say as a DBA, and what I always think, is that if you notice anything I'm doing, I messed up. I should be able to do things to the database and you don't notice it if you know what you're doing. But if you make a mistake, such as creating an index on a big table with Standard Edition, people are going to notice and you're going to get in trouble, and you don't want that. So these 2 queries together can help you dial in your indexes to a certain extent, because you don't want to have too many and you don't want to have too few. And this helps you work on that equation, which is really, really important as a DBA. Now the next one is missing index warnings for cache plans. And so this is going to give you store procedures, and then you can actually see the query plan, and then it tells you how many times that it wanted it. So this helps you tie those missing indexes to particular store procedures that SQL Server thinks that it wants an index for, and then it'll help you decide whether you want to create that index or not is the point here. Now the next one, which can take a little bit of time on a production server in some cases, it's going to show you how much memory in the buffer pool every index is using. An index ID 1 is always the clustered index, so the clustered index for this table is using that much space in the buffer pool. And it also tells me the row count for that table and the fact that I'm not using any data compression on that index. If you have Enterprise Edition, you can use either row compression or page compression. It can be a really big win in some scenarios. And that's what I like to use this for. If I find a table that's using lots of space in the buffer pool and has lots of rows, and I'm not using compression, then I'm going to start to do some more research and think about, well, maybe I can compress that index and get a lot of memory space back in the buffer pool and reduce my I/O workload. All right, the next one is going to look at all my tables and give me their row counts and their compression for the clustered index or the heap if it's a heap table. Then I'm going to get some key table properties here. This is going to tell me when the table was created and a few other things like whether it's in replication, whether it's in CDC, what the lock escalation is, whether it's a hackathon table or not. This one here is going to give me blocking information. And again, you can't just run this once. You need to run this a number of times, especially if your average task counts are high and it looks like you're seeing some blocking and deadlock issues. If that's happening and you run this, quite often it'll come back and tell you which tables and indexes are involved and help you troubleshoot that pretty quickly. The next query is going to tell me when the statistics were updated in all the indexes. And I want to know that because maybe I've got a problem where statistics updates have been turned off and nobody's doing any manual updates, and so my statistics are really out of date and I'm getting poor quality query plans because of that. Moving on, this is going to tell me which indexes have been modified the most often, which indexes and statistics I should say. So this is showing the number of modifications that have happened to this index and this index, and then here's a system-generated set of statistics that it's also seeing a lot of updates to. Next, I'm going to find out which indexes have the most fragmentation, and this is using the most lightweight limited option for this particular DMF. So when I run this, it shows me my average fragmentation in percent, and these are all very, very low. But if you see this, above about 40 to 50%, then you probably need to do a little bit more index maintenance, or at least change how you're doing it. All right, moving on, and we're almost done here, as index read-write stats. So this is going to show me which indexes have seen the most reads in this database. So these are the most valuable indexes. So that's the number of reads and the number of writes. And whether or not you've got, it's a filtered index, and what the fill factor is, a lot of good information about your indexes. Then we do the same thing for writes here. And when you see ones that have lots and lots of writes but 0 reads, again, that's something you want to think about. Do I need this index or not? After you do some more research and you make sure you've been running long enough for these numbers to be valid. Then I'm going to see if I'm using hackathon, whether or not those indexes are being used. And I don't have hackathon on here, so nothing comes back. This next one is going to give me my lock weights. So if I'm seeing locking and blocking and deadlock top issues, then this will help me figure out, okay, which indexes are seeing the most lock weights. And that might point me in the right direction. Hey, maybe there's a problem with this index. And then the last one in this set is going to show me all the most recent full database backups, when they happened, what kind of a backup it was, how big it was without compression, and then this shows that I used backup compression and what the compression ratio is. So that's a complete set of queries, and then I've got links here to my Pluralsight courses that give you more detail about how to run these and interpret them. So that's pretty much it for running through the whole set. If there's any questions that have popped up, I'm happy to take them now.
Okay. It looks like we've got quite a few questions. The one big question is people want to be sure that they have access to these queries so they can try them out themselves along with the recording.
Okay.
So I'm guessing you'll get us the scripts afterwards, or we can get them off of your side, or
Yeah, I mean, what I'll do is I'll put a blog post up today that zips up this presentation in PDF form along with this set of scripts. But you can all, anytime you want to, just Google Glenberry DMV. Do it now if you want, and you'll see, you'll find it. It'll take a link to where you can get these from. And I update them pretty much every month. I just put the latest version out a couple days ago, I think. So.
We will probably have the recording up in a couple of days at least. So that's what I'm going to do is I'm going to go back and take the scripts and go along with the recording and stop at certain places and really delve into this stuff. This has been great today. Let's see. We do have a bunch of questions. Let me go through them real quick.
Okay.
Or can you see the question list and pick out the ones you want to answer? I can tell you one. This was from earlier on. We have trace flag 1117 able for even growth of 10 DB database files. Is that the same as 1118? I know 1117 applies to all multiple files in a file group on all databases, not just 10 DB. Is 1118 the same thing for just 10 DB?
Now 1118 is for all the databases on the instance, and I believe 1117 is only for TempDB, and it does something a little bit different, but I'm not 100% sure on that. They're similar, but I know 1118 is for all the databases.
That's the one that's what I thought. I tried to answer the question, and it's the one that you have to kind of be careful with to be sure it doesn't affect. You know it's going to affect other databases on the instance, so you want to be sure that that particular effect is okay for the rest of your databases. This person wanted to know how to crack open and read a dump file. I think that would take a long time to do that, but
yeah, it's something I think you need to use a Visual Studio debugger and to really do it properly.
Okay, this person asked whether or not the scripts work for both physical and virtual servers. I would assume it does, but there might be a little bit of different information for different scripts.
Yeah, well, the thing is, if you're running on a virtual machine, you're going to see the virtual machine's view of the world when you run these scripts. So, all the hardware level and instance level things are going to see what the VM knows about the world. So, yeah, you can use it on a virtualized instance the same exact way. Just realize that you don't understand what the host might be doing when you do that.
Okay. This question was how to shrink the log file in the database where they are part of an availability group. I'm not sure.
How do you shrink the log file when you're part of an availability group?
Mm-hmm.
Well, you do it on the primary replica, and then whatever you do on the primary replica gets played on the other replicas, and then they'll conform to that is how it works.
Okay. Can you specify a stored procedure to find execution and worker time?
Well, what you could do on those queries that I showed that I call the bad man list queries, you could filter to a particular stored procedure, and then some of the other examples I have show ways of once you run the query, you could get the query plan. So yeah, you could do that. You have to modify one or two of my queries to do that, but yeah, I can do that.
Okay. This question was, is there a good formula to get the PLE?
Not really. I mean, Jonathan Quijayas, one of my colleagues at SQL Skills, wrote a blog post where he has a way of coming up with what you should set max server memory to. But as far as a formula for PLE, I don't think there's really a good formula. It depends on how much physical memory you have in the box and just the trend over time. It's not the absolute value right now. You just want to understand, it goes between 5,000 and 20,000, at different times of the day. But other than that, I can't really just say a number. Just don't go by the old number of 300.
Okay. If someone runs a SQL query from within an Excel workbook as a regular process, do these get treated as ad hoc queries and not go into the system plan?
Well, that would depend. I would imagine Excel rather would send that as an ad hoc query. I doubt that but I don't know. It's possible that it might be parameterized, and maybe they're calling SB execute under the covers. I don't know how Excel would do that, but so if it's not parameterized, it's probably just going to show up as an ad hoc plan.
Okay. This person wants to know if you have a blog post or any other place where they can verify what are the expected normal values of these DMVs.
Not really. I mean, what I would suggest is I have notes underneath each query that sometimes tells you what's good and what's bad. And then my Pluralsight courses, I go into a little bit of detail about what I think is good and bad, but I'm not going to come out for every single query and give you, hard and fast values, because a lot of it depends on what other things and what your workload is and what your hardware is.
Okay. Query 36 shows that there are more than 40 connections from the SA user, and query 37, active connections, only adds up to 5 from various users. This does not stack up. Could you expand a bit on this, please?
I'd have to look at that. Whoever had that question, send me an email, and I'll look into it and get back to you.
Okay. If not, they can...
Because one's by IP address and one's by log, and for the user, so I'd have to look into that.
Okay. Okay. I'll just read this entire thing. There are a lot of queries here you offer. Given that you have so many options to investigate, what would you say is the average investigation time to max optimization to a point where you can run these queries and don't see any or very few problems?
Well, that's a good question. I mean, all the instance level queries, a lot of them have to do with, configuration settings, like do you have optimize for ad hoc workloads enabled, or what's max stop set to, what's max server memory set to, things like that. You can run it once, and at least I can tell people, here's what I think you should set it to, and that's pretty quick, and I can give them the background and back up why I think it should be set to that setting. But when you get to some of the other ones, it can be an iterative process, because maybe you run the query that tells you which is the most expensive store procedure. So then you go in and tune that guy, and then he drops down the list, and somebody else comes up at the top of the list. And so you work on that one. And then as you make changes, like if you add an index that SQL Server really, really needs, and it turns out to be a really high impact, valuable index, that could change all sorts of other things. Maybe your page life expectancy starts going up because of that. Maybe your CPU utilization goes down. So these things, you'll have to probably run them more than once as you're making changes to see what's going on. So, the initial easy stuff is quite quick, but then the other stuff can take multiple iterations to get it tuned in.
Okay. For a delta load in a DWH, how do you suggest to handle IDX on DIM and fact tables? I guess it's handle indexing on DIM and fact tables.
Well, I mean, I'm not a data warehousing expert by any stretch of the imagination. I guess you're talking about a star schema there, and
I think that's what she's talking.
Yeah, I know. One thing I do know is quite often data compression really, really helps with data warehouses, but as far as other than that, I don't really want to say too much about data warehouses.
Okay. This question is there a disadvantage when compatibility level doesn't match the installation on the instance?
I'm sorry, can you repeat that?
I'm assuming they're saying is there a disadvantage when your compatibility level on your database doesn't match the installation on the instance?
Oh, okay. All right, now I understand. Well, I mean, you can change the compatibility level for an individual database, and what usually happens is somebody upgrades from an old version of SQL Server to a new version, and they restore the database there, and that doesn't automatically change the compatibility level. And the only downside to not changing that is that some of the new features may not work 100% if you don't change the compatibility level. And the reason why people don't change it is sometimes when they change the compatibility level, some things can break. It doesn't happen very often, but it was kind of an issue when you went from 2000 to 2005. So you can change it back and forth, and unlike the actual file level of the database. So that's the only real disadvantage. I'll take that back, though. SQL Server 2014 has a new cardinality estimator, and that is turned on by default when you upgrade to the latest compatibility level. And sometimes that can cause lots of query regressions. I've seen it happen a few times. Most of the time it works better, but sometimes it causes issues. So you can override that at the query level with the trace flag, for example. So that's the one big exception to that. But other than that, there's no real downside to having a lower compatibility level or a higher one. It just makes the features work differently in some cases.
Okay. You touched on DBCC free system cache. What repercussions, good and bad, should be understood before running that?
Well, what's going to happen if you run that is all the plans that are ad hoc or prepared plans in the plan cache will get flushed out. And people usually, when they talk about clearing the cache, you see all these caveats. Oh, don't ever do this on a production server or the world will end. Well, I find that in my experience not to be the case for most people's servers. Modern servers have lots of processing power, and the processors are so much more powerful than they were a few years ago. So all that happens when you flush out of the cache is the next time it gets executed, it has to be recompiled and go back into the cache. And even if you're recompiling lots and lots of plans, you might just see a little blip of the CPU for a few seconds. But very rarely, in fact, I haven't seen it at all for years, where this just brings a server to its knees for a long time. I mean, you might have some edge case workload, that's going to be an issue, but normally it's just a little blip. Nobody even notices. It just gets rid of all those plans that are wasting memory space is a good result, and there's no down result.
Okay, this person has the question that might be a little outside of what you're looking at, what we've talked about. Database goes into recovery mode. What is your recommended way or best practice to restart the SQL services?
So the database goes into some like suspect state, or it's still in a recovery pending mode. I mean, I'm not quite sure what they're getting at there. It sounds also more like a corruption type issue.
I think it is. Maybe they can just do that one offline with you. And just
yeah.
This is the last question. He said recovery pending mode.
Okay. Well, what probably is going on, what could be going on there is that you have a lot of VLFs and it's still going through recovery, and reducing the VLF count, which you can't do until it comes back online, would help alleviate that issue. And it could also be that your I/O subsystem is just really slow, or you have lots and lots of databases. But yeah, anyways, moving on to the next question.
Okay. This is the last one. How do we go about troubleshooting with wait stats? I know there's a lot of stuff on Pluralsight about that. I know there's a lot of information, but what can be a good place to start? Can you point us in the right direction?
Yeah, I mean, Bob Ward from Microsoft wrote a blog post back in 2009 where he started to document the wait stats and what they mean and what you should do if you see them. And then he sort of got distracted and never really followed up on it. So Paul Randall, my boss, he's talked about this a little bit. He's going to be doing something like that in more detail. And so look for that coming fairly soon, hopefully. But beyond that, there's some good stuff on Pluralsight that explains how to look at wait stats, and Paul Randall's written a number of good blog posts on how to look at them and what ones to worry about and which ones not to worry about as much.
Yes, I just actually went through that. You had a presentation of another DC about 3 weeks ago on wait stats, and from there I went to Pluralsight and went through his course on it, and it was fantastic.
Oh, good. Happy to hear that.
I think that's about it. At the last presentation, I don't know if Paul was still able to provide that or not. He had an offer for people to get 30 days free at Pluralsight if they send him an email. Is that offer still open?
I don't know, to be honest. And Paul, he's like on a plane right now, flying to Australia, I think. So But if anybody's interested in that, send me an email and I'll try to find out if that's still available or not.
Okay. Well, we appreciate it. I think a lot of people are going to take out a lot out of this presentation when they go back and look at the queries along with the recording and are able to go in and absorb things. They're going to love this stuff.
Well, good. I appreciate everybody listening, especially it may be blizzards and snowing where you're at. So.
Our winner of the Amazon $25 gift card is Sarah Anderson. And we'll have another presentation coming up soon with Denny Cherry. March the 3rd, I'll be sending out an email on that. And in the meantime, this recording will probably be up and available by the weekend. And again, you can get the scripts just by Googling Glenberry DMV. He keeps these scripts up to date for all versions. And he loves for you to use them. Thank you.
All right, thanks everybody.